In the last video, we walked through how data engineers design, build, and maintain data pipelines. We saw that one of the most important design questions is, how fast does data need to move? But here's the problem. When stakeholders ask for a fast data system, they usually mean very different things, and those differences matter. In this video, we're going to break down what fast actually means in data engineering by looking at the two types of latency you need to understand: data latency and query latency. And we'll see why optimizing one often makes the other worse. Imagine a stakeholder comes to you and says, "Our data warehouse is too slow. We need it to be faster." That sounds reasonable, but it's actually ambiguous. Do they mean, when I click Run Report, I don't want to wait 30 seconds for the chart to load? Or do they mean, I want the numbers in the report to reflect what happened seconds ago, not yesterday? Both problems involve speed, but they're completely different engineering problems. And confusing them is one of the most common sources of frustration between business users and data engineers. To fix that, we need to separate speed into two distinct concepts. In data engineering, we talk about two kinds of latency. Data latency, how fresh the data is. Query latency, how fast the system responds to a request. Let's look at each one. Data latency refers to the time between when a data event is generated in a source system and when that data becomes available in your data warehouse or data lake for analysis. In other words, data latency measures the lag in the ingestion pipeline. It answers the question, how old is the data I'm looking at right now? For example, let's say a transaction happens at 9 a.m., but your ingestion pipeline runs as a daily batch job that finishes at 2 a.m. the next morning. That transaction will not appear in reports until the batch finishes. So in this case, the data latency is about 17 hours. Nothing is technically broken. The system is working exactly as designed, but the data is not fresh. But why does data latency exist? Data latency exists because data cannot teleport instantly from creation to availability. It has to move through a series of steps. Typically, those steps include extraction. How often do we pull data from the source? Every 24 hours, every 5 minutes, or immediately when an event happens. Next, transmission. The time it takes to move data across the network from the source system to another location. Often data is not loaded directly into the warehouse. It first lands in a staging area, which acts as a buffer, so we don't overload the operational database. Finally, transformation and loading. This is where we clean the data, fix formatting issues, apply business rules, and finally load it into analytical tables. Each of these steps introduce delay. When you add them together, you get data latency. Now let's look at the second type. Query latency refers to the time between a user clicking Run Report or Refresh Dashboard and the system returning results to the user. This is the delay users feel directly. It answers the question, how long do I have to stare at a loading spinner before I see results? Query latency is driven by the computational performance of the analytics system. Key factors include indexing, hardware resources like CPU and memory, caching, query optimization, and how data is physically organized on disk. You can have very fresh data but slow queries, or very fast queries but stale data. These two dimensions are independent, but they interact in important ways. Here's the counterintuitive part. In many real systems, optimizing for one type of latency hurts the other. Optimizing data latency can hurt query latency. If you push data into your system as soon as it's created, near real time, you end up with a constant stream of new records with very little time to pre-aggregate or reorganize the data. When a user runs a report, the system often has to scan large volume of raw or semi-processed data and compute results on the fly. That increased query latency, even though the data itself is extremely fresh. On the flip side, Optimizing query latency can hurt data latency. If you want reports to load instantly, you often have to pre-calculate aggregates, enforce strict schemas for data validation, and store results in optimized summary tables. But all of that processing takes time. So instead of ingesting data continuously, you batch it up and process it periodically, maybe once an hour or once a day. That lowers query latency, but increases data latency. At this point, you might ask, why not just make everything real-time and fast? That's a reasonable question, and a very expensive one. Reducing latency doesn't increase cost linearly, it increases it exponentially. For example, going from 24-hour latency to 1-hour latency might double your cost, but going from 1 hour to 1 second might increase cost by 10 or even 20 times. Why? Because low latency systems require more infrastructure, more redundancy, and more operational complexity. We'll dig into the cost side in detail in a later video. For now, the key takeaway is lower latency is not free. You are always trading cost and complexity for speed. So when someone says, we need the data system to be faster, the correct response isn't to jump straight into optimization, but to ask a follow-up question. Fast in what sense? Do you need fresh data? That's a data latency problem. Or do you need snappy dashboards? That's a query latency problem. Once you clarify that, the engineering decision becomes much clearer. This distinction directly influences architectural choices. Batch versus real-time ingestion affects data latency. Indexing, clustering, and pre-aggregation affect query latency. And because these optimizations often pull in opposite directions, architecture is always about trade-offs, not perfection. There is no single fastest data warehouse. There is only a system that is fast in the way your use case requires. So in this video, we learned that fast could mean different things in data engineering. Data latency measures, freshness, query latency measures, responsiveness. Optimizing one often hurts the other, and lowering latency comes with real cost and complexity. In the next video, we'll zoom in on data latency specifically and answer, how do data engineers actually reduce it? Why does batch processing create high data latency? And how do streaming systems and event-driven architectures change the picture? That's where we'll take a deeper look at batch versus streaming and the design of ingestion pipelines. If you found this helpful, like and subscribe so you don't miss the next part of the series. See you next time.